Okay, here we are, back to school. Let's get to lab, get some lab work done. How's everybody doing? Hey, how's it going, Art? Nice to see you. What's up, Bears?
There's always one.
To start our reaction, we're going to add the thiamine hydrochloride catalyst to our empty 50 milliliter Erlenmeyer flask. So here's our reaction flask. That's a 50 milliliter Erlenmeyer, which I got my initials labeled on there, my date, and benzoin, what we're going to make in there. This is our thiamine hydrochloride catalyst. Here's the structure again for it. And we put the empty flask on the scale first to see how much it weighs. It weighs 31.8405 grams. And that's our empty flask weight. We're asked to add 1.2 grams of thiamine hydrochloride. So we want this flask and thiamine hydrochloride added to have a total mass of 33.0405 grams. And the thiamine hydrochloride, then, we scoop some out with our micro spatula. And my animation makes it look like I'm adding this solid to the flask in the scale, but I remove the flask from the scale as I was making my additions. But when I add the first portion, I need 33.0405 grams. I get not quite that much. I get 32.5051 grams, so I'm heading in the right direction, but I need to add more. So I go back, scoop out some more, bring it back to the scale, and now I'm at 32.661 or 21 grams, so I'm getting closer to the desired amount. Add another portion, and now I'm at 33.0543, a little more than it's called for, but close enough. So what you should do now is determine the amount of thiamine hydrochloride that was actually added, put that into your reaction table. Next, I added water to the benzoin. So I needed about 1.8 milliliters of water. I used a 10 milliliter graduated cylinder and I measured that water out, and I picked a poor background for my graduated cylinder, but it was at about the 1.8 milliliter mark. So I added that into the thiamine hydrochloride catalyst in the reaction flask. So record that value, 1.8 milliliters, into your reaction table now. So let's see if we can get this dissolved, swirl it around a bit. Not completely dissolved, but I'm going to actually move on. I'm going to add the ethanol. So I need to add 12 milliliters graduated cylinder. 12 milliliters of ethanol. So what I'm going to do is I'm going to take my Erlenmeyer flask that had water in it still. Not that it's that big of a deal, but I'm going to put some ethanol in there, dump that to condition it. So now maybe I'll do that one more time. So I'm rinsing out the water, but there's water in the reaction. It's not that big a deal, but let's just get this conditioned. And then this is a 10 mil graduated cylinder, so I'll fill it up to 10. If I just pipette it, it's going to take a while. Not forever, but if I get a short stem funnel, it'll be a lot quicker. I conditioned my short stem funnel as well. So now I've got my short stem funnel on here. Let's see if I can do this without spilling it too much. Not bad, huh? And then finish it off by pipetting to 10 milliliters. Let's see, that is pretty good, I'd say. Yeah, it's close enough. So that's 10. We're going to do a total of 12, but I'll get the first 10 in here. Let's look at the solution now. This is just with the water. It looks like It's dissolved a bit more as I was waiting. I'm not worried though, because I'm going to add the ethanol and that's going to dissolve it. So I've got my 10 milliliters of ethanol and swirl that a bit. And then, oh, I did spill a little bit, so all my precision's gone now. That's okay. So, yeah, you can see I spilled a little bit on the counter. Whoops. All right, so let me add 2 milliliters now more of ethanol. That's about 2 milliliters. A little bit more, but that's okay. I spilled. So here we go. We'll add the last of the ethanol. Okay, next up is the 2 molar sodium hydroxide. That's going to make sure that'll get it all dissolved. There's still just a little bit undissolved in there. Can you see it? Let me give you a better angle. Right there. I'm not worried. I'm going to be adding the sodium hydroxide, and that will deprotonate the thiamine hydrochloride and will make it even more. Yeah, it'll make it more soluble. I think it will. Yeah, interesting. So let's review those really quick. So if you have a molecule like a carboxylic acid that has a lot of organic nature to it, all this is organic, soluble, nonpolar, and then you have the polar end here. It doesn't look too water soluble to us, but when you add a base and deprotonate it, it becomes charged, and now that it has a charge, the water molecules are more attracted to it. It's much more soluble. The water molecules can hydrogen bond with their hydrogens to that. So the organic soluble neutral molecules here, and then the aqueous soluble charged molecules here. So yeah, I don't know if you can hear that water sound. I can. And then a carboxylate, it already has a negative charge. If you add acid like hydronium, it'll protonate it, and it goes from being, well, I'm numbering my carbons. I'm good here. I don't want to miss any. From being aqueous soluble with a negative charge initially to neutral. All right, so same can happen with amines. Protonate an amine to make an ammonium. Now it's more charged, and it's charged and now water soluble. All right, so deprotonate, we make it, in this case, organic soluble. So how's that going to work with our thiamine? So thiamine's interesting in that it's a Zwitter ion in one form of it. But let's first look at the solvent. So water is added to our reaction, and ethanol. What do we have more of? Well, we added 1.8 milliliters of water, pure water, and then we added 3.6 milliliters of the 2 molar NaOH, which is mostly water. So we have about 5.5 milliliters of water. How much ethanol? We just added 12 milliliters of ethanol. So we actually have more ethanol than water. I'm going to show ethanol being made into the base for this reaction since we have more ethanol than water. So I'm going to deprotonate the ethanol with the sodium hydroxide that was added to make ethoxide. And then the ethoxide, that's going to react with our thiamine hydrochloride. It's going to deprotonate that hydrogen there because remember, it creates an anion adjacent to the sulfur atom, and the sulfur atoms are known for stabilizing these type of anions. And our nitrogen here has a positive charge right next door to this negative charge. This is called an ylide when you have that, and an ylide is a type of Zwitter ion. So now we have our organic molecule has an overall positive charge, and this organic molecule has no charge. So usually when we deprotonate things, well, if we deprotonate an organic molecule, we usually wind up making it more water soluble. But did we in this case? Because now we made it a molecule with no charge. So I don't know. This one has a positive formal charge on the nitrogen, where the other one has a positive formal charge on the nitrogen and a negative formal charge on the carbon. So which one is more soluble in this ethanol and water mixture, these polar solvents? I don't know. I think maybe this one's more water soluble or ethanol soluble, but I'm not 100% sure. It's an interesting question. In our reaction, we'll see how the yield works and see if that maybe played a part in it. All right, now I'm gonna go ahead and dry out that ethanol, that little bit of ethanol that's in here. I'll make sure my tank is loose and off here. Open the top. This gauge tells me how much pressure is inside the tank. That tells me what I'm releasing when I screw this in. There it is. Put this in there and I can do a quick dry on that little bit of ethanol that was left in there. Just evaporating it away. It's not actually that necessary for the next step, the sodium hydroxide, but I'm going to do it after the sodium hydroxide. I'll wash out the sodium hydroxide with water, and then I'll clean it. Then I'll rinse it with acetone and dry out the acetone quick with this. So I turned off my gas pressure here, and then I'm going to close it off at the top of the tank as always too to save it. All right, I need about 2.6 milliliters of, or 3.6 milliliters of sodium hydroxide, the 2 molar. I have that here. 2 molar sodium hydroxide, so I will pipette that over. .6 milliliters, okay, 3. Almost. About 3.5. I think that's pretty good. This is a brand new pipette. I don't mind putting that sodium hydroxide back in there. 3.6. Yeah, I think that's pretty good. So I'll add that to my flask. Oh, before I do, when I added the water to this, to the thiamine hydrochloride, I gave it a little bit of a waft and I smelt it. It smelt very similar to like a protein powder drink. If you ever had those like muscle drinks. And so that was the smell I had before. Now when I add the sodium hydroxide, ooh, look at that. Isn't that cool? The color change quickly. I'll get a nice color change when it starts to deprotonate things, the sodium hydroxide. And then I swirl it around. Do I get some? I still have undissolved solid bits. I don't know why, but I'm hoping that won't be a problem. And so I'll swirl it around, and then the instructions say to swirl it until the bright yellow becomes a duller yellow. So is that happening? I don't know. Maybe it's a little dull. And so now this guy, when it's been when the solution's been made basic, it might have a different smell. Let's smell it. I can't really smell much. I'll get it closer to your nose. No. Actually, I don't smell much of anything. So I'm going to work hard to avoid letting oxygen into this reaction. So I'm going to blow some nitrogen gas in here to start. So this is off. Open the tank at the top. Slowly start to open this until I get some flow. There we go. So I'm going to blow some nitrogen gas into here. As I do that, then I cork it. I'm pushing out any oxygen that was inside of the flask. Those are at the top. All right, let's walk over to the scale. And we're going to get a weight of this with the cork on. So we're weighing it before we add the benzaldehyde. So this will be our weight right before benzaldehyde. Okay, so I'd rinsed out the Erlenmeyer with tap water and then some deionized water. Don't necessarily know I needed deionized water, but now I'm going to finish off with a little bit of acetone. And of course, I won't put that down the sink drain. after I've given it an acetone rinse, I want to dry out that acetone. I don't want acetone in my reaction. And acetone evaporates quickly. So if I move over to the nitrogen tank, I can evaporate away this acetone. So this is loose. Opening this guy. Give this a real good drying. So I have a nice clean Erlenmeyer graduated cylinder that I can cannulate my benzaldehyde into. If I wanted to, if I wasn't in a hurry, I could just let this air dry for a couple days. Alright, I'll say that's good. Okay, cannulation's up next. I'll be adding my benzaldehyde to the reaction via what's called cannulation. So our benzaldehyde, if you look at it, it needs to be very pure. In this bottle, it says that it is greater than 99.5% pure by redistillation. So redistillation means it was distilled to purify it, and then after the distillation was collected, it was distilled a second time. So this one's very pure. If you look, it's a sure seal cap, that's what they call it. I'll show you what that means. When you open it up, it doesn't have an opening, it has a septum there. This has already been used before. When it's brand new, it doesn't look like jet black like that. But so we'll put a needle into that septum to get our benzaldehyde out of the bottle with exposing it to a minimal amount of air as possible. The reason why that is benzaldehyde, it is easily oxidized from its liquid form, see how it's a liquid here, into benzoic acid, which is a solid. So if you take this benzaldehyde and you took the sure seal cap off, the septum, left it out in the air for a day, say, it'll start to develop benzoic acid crystals in here. You'll see little solid bits. So if you have an old bottle of benzaldehyde, you could tell because you'll see solid benzoic acid in there. And it's what it is, it's the oxygen in the air that oxidizes the benzaldehyde to the benzoic acid. So our reaction, it seems to be sensitive to benzoic acid impurities. So we buy the expensive, redistilled, very pure benzaldehyde, and we cannulate it into our reaction. So what does cannulate mean? It means this. We'll take a cannula, which are these guys. Got a pack of them here. And this is what they are. They're basically a straw, and they have a needle tip to both ends. So it's a tube. And we're gonna be able to cannulate benzaldehyde through one end. I don't know if that's focusing for you. I'll show you a picture of it. So I have a needle on one end, a needle on the other, and it's a tube. So we'll be able to put this cannula needle into the bottle of benzaldehyde, put the other end into a graduated cylinder, and push the benzaldehyde liquid into the graduated cylinder. I'll show you how it works. So to do this right, you got to make sure you're going to need a needle, and you want to make sure it's clear and it flows well. So I'm going to make sure this is loose, open my nitrogen tank, turn it on, hook up my needle, and then feel that I get some, I can feel the nitrogen gas coming through. So that's good. Turn that off. Then I'm gonna also check my cannula. So I can put the cannula in here and kind of hold it like that. Turn on the nitrogen gas and make sure, I feel a nice flow of nitrogen gas hitting my skin right there. So that's good. So the cannula looks good and the needle looks good. So I'm gonna take the needle, attach it to here, and what we'll do is we will put the needle into the bottle to blow nitrogen gas into this bottle of benzaldehyde, and then the cannula will also be in there, but the cannula will be down into the liquid of the benzaldehyde where the nitrogen needle is above the liquid. but the nitrogen pressure that will build up in the bottle will force the liquid to go through the cannula and over into our graduated cylinder. So I'll show you that now. Okay, here we go. I'm gonna get my nitrogen gas flowing. Yep, I feel some nitrogen gas flowing out of this needle. Then I'll attach it. I'll stick it through the septum. Then I will add my cannula. Okay, so the nitrogen's putting pressure in the bottle. So the cannula right now is pushing nitrogen gas and benzaldehyde fumes out of its tip. I won't get benzaldehyde liquid to come through until I push the cannula needle all the way down into the liquid. It's not into the liquid yet, so now it's just gas. And this is something I wish you guys could be here for. It's one of the best smells we have all year. This benzaldehyde, when you wafted at it, the fumes coming out, it smells of cherries and almonds. Reminds me mostly of cherries. Because benzaldehyde is one of the main flavor components in cherries and almonds. So it's a nice smelling one. So now I'm going to take and, I better lower this a little bit. All right, so I'm gonna take and add my cannula over into my Erlenmeyer, or my graduated cylinder, and I'm gonna measure out 3.6 milliliters. The way I'll do it is I'll push the cannula needle all the way down into the liquid. Once I get it into the liquid, it'll start dripping into there and filling it up. And then I'll pull it out of the liquid, put it back in the liquid, until I get to about 3.6. Not too bad. I'm a little bit below. I'll go a little over, I don't mind. I went to about 4 milliliters, not a problem. Then I'll take my cannula needle out of the bottle first, then remove the nitrogen and quickly cap, and now the bottle is under pressure of nitrogen, which means it's harder for oxygen and air to get in there. All right, I don't want to waste too much time on this. Now I want to add this benzaldehyde to my reaction flask. I'll go grab it. This is nice. As we've been working, all the little solid dissolved. Well, did it? Yeah, I think it all dissolved, yep. So now I'll quickly add my benzaldehyde that we cannulated over. Trying to limit the amount of time the benzaldehyde's in air. And then it should be fine now, but I'm gonna blow some nitrogen in there just the same, to push out any oxygen. And then I'll cork it. Okay, now it should be fine from the oxygen. So the reaction is ready to go now, and I want to run it under dark conditions. So I'm going to put it in a locker in the dark. Oh, actually, before I do that, I got to weigh it. So let's bring it over to the scale. Here's the lab again, you guys. Missing it. Here we go. Let's get the weight of now the flask and everything, and the cork. Okay, night night, little guy. I'll check you in a couple days. Into the darkness you go. So come back to my cannula. I gotta make sure to clean this out right away. The reason being that, remember, the benzaldehyde over time will get oxidized to benzoic acid, which is a solid. So if I get benzoic acid solid forming inside of this cannula, it'll clog it up. So if I clean it right away by pushing some acetone through it, and then rinsing it and then drying it with the nitrogen gas, it keeps my cannula nice and clean and lasting a long time. Okay, I cleaned out my cannula, and I have my Erlenmeyer, my graduated cylinder. I keep calling it Erlenmeyer today. And it's got a little more benzaldehyde in the bottom there. I'm gonna pour it out inside of the fume hood, that little last bit of benzaldehyde, there it is, right? And we'll do a little side experiment. We're gonna check this out in the days to come. I might be coming in tomorrow. And if I'm telling the truth, then this nice sweet smelling benzaldehyde liquid will get oxidized from oxygen in the air reacting with it, and instead of being a liquid, we'll see a white solid there, which is benzoic acid, which is a preservative that was in diet sodas and things like that. So let's check it back. Let's check back on this in a day and see if that liquid benzaldehyde is becoming a white solid. So coming back after a number of days, it looks like there's no solid benzoic acid here. It looks probably what happened is the benzaldehyde liquid evaporated in the fume hood with the airflow over it quickly before it could be oxidized. So I'm going to try this again, maybe with more and outside of the fume hood. But yeah, I guess I lied to you. Maybe it doesn't get oxidized by oxygen.